So the next example we've got a large group of people, 10% have hot breakfast, 20% have hot lunch, 25% have a hot breakfast or a hot lunch. Find the probability a person chosen at random has a hot breakfast and a hot lunch. Which technique that we've used so far do you think might be the best way to go about it? I can see some people are drawing it already, yeah. Start off with a Venn diagram. And we're interested in hot breakfasts and we're interested in hot lunches. We know 10% have a hot breakfast and hot lunch is 20%, and altogether hot lunch or a breakfast, that's those three numbers added together here, that one and that one, make 25. Now can you work out from there what goes where? There's going to be 10 in that circle, 20 in that circle, and altogether there's got to be 25 in all three bits. Can you work out from there what's got to go where?
5 in.
Why 5 in the middle? Because you're correct.
Because there's 25 have either, and then add the other two together to get 30.
And the difference is 5. Yeah. So that's correct. Okay. I'll do it a different way in a minute, but that's correct. If you just look at it, these two numbers here make 30, but altogether it's 25. So it's like there's 5 people that have to be double counted. So the 5 has to go in there. So we said 10 had hot lunches, so 10 need to be in this circle. I've got 5, I need another 5. Hot lunches, I said, was 20, and I've got 5 there, so that's 15. And then just check. It said 10% have hot breakfasts. I do have 10 in my hot breakfast circle. It says 20 have hot lunches. I do have 20 in my hot lunches circle. 25 have a hot breakfast or a hot lunch. If I add all of those together there, I do get 25. So that works. What's the answer then to the question? The probability a person chosen at random has a hot breakfast and a hot lunch? Yeah, it's that number there, it's 5. So the answer for that one is 5%. If you can't just see that and want to do it another way, let's just write down, using a bit of probability notation, the information we've got in the question. It said, I'm just going to use B for breakfast and L for lunch. The probability of a breakfast is 10%, so that's 0.1. It told us the probability of people having a lunch is 20%, that's 0.2. It told us the probability they have breakfast or lunch, and or is the union, that U symbol, was 0.25. So anybody who can remember a formula that links things together involving the union formula, the union symbol rather, and those two?
So would it be P, B union L equals PB plus PL, take away P, B and L?
Yes, that's exactly right. Okay, so you can see that as I wrote it down. The union of events is the first event plus the second event, take away their intersection. That's exactly right. Okay, that's what we had last lesson. So if you just write these numbers you know underneath here, union I know is 0.25, the B is 0.1, the L is 0.2, that's the only one I don't know. And you can just rearrange that equation, because you've got here 0.25 is 0.3, take away something. Well, that something has got to be 0.05, which means 5%. So you could use that probability formula we had last time that links together the union, the two events, and the intersection.
Could you not do it probability of B, probability of L, take away probability of BUL?
That's exactly what we do. If we rearrange this thing here, that's exactly what you would get. Okay? What you've just said is those two, take away this one, and if you shift that over there, that becomes a minus, and that would have to go on the other side. So yeah, it's exactly right. It's exactly what you said. I just wanted to show you as well that it does fit into that formula. Okay? Any other questions, queries about that one? Okay, can we get the next question stuck down there, please?